For generations, humanity has searched the night sky for a simple answer to one extraordinary question. Are we alone? Every new telescope, every space mission, and every technological breakthrough has brought us closer to understanding our place in the universe. Yet despite discovering thousands of worlds orbiting distant stars, no observation has provided undeniable evidence that another intelligent civilization exists. But what if the first sign of alien intelligence isn't a radio signal? What if it is light? Imagine looking toward a distant planet and finding tiny points of illumination scattered across its dark hemisphere. Not reflections from its star, not volcanic eruptions, and not lightning storms, but organized patterns that remain visible night after night. On Earth, our cities transform the darkness. From orbit, continents glow with networks of highways, towns, and sprawling metropolitan areas. These lights reveal more than electricity. They reveal technology, engineering, and civilization. Astronomers have begun asking an intriguing question. Could a sufficiently advanced telescope someday detect similar artificial illumination on a distant world? Today, the answer is no. The signals would be extraordinarily faint and hidden beneath the overwhelming brightness of the planet's host star. But future generations of observatories may possess the sensitivity needed to search for these subtle clues. Scientists refer to possible evidence like this as technosignatures. Unlike biosignatures, which search for gases such as oxygen, methane, or water vapor that may indicate simple life, technosignatures focus on evidence of advanced technology. Artificial lighting, industrial chemicals, unusual heat patterns, powerful radio transmissions, even enormous structures capable of altering a planet's environment. None of these have been detected on any known exoplanet. Yet researchers continue developing methods that may eventually allow such searches. One world frequently mentioned in these discussions is Proxima b. Orbiting the nearest star to our solar system, Proxima b lies just over 4 light-years away. Although little is known about its surface, its location inside the star's habitable zone has made it one of the most fascinating planets ever discovered. Could oceans exist there? Might its atmosphere support liquid water? Could life have emerged under completely different conditions than those on Earth? No one knows. But questions like these have transformed Proxima b into one of astronomy's most important laboratories. Helping scientists investigate worlds like this is one of humanity's greatest scientific achievements, the James Webb Space Telescope. Positioned nearly 1.5 million kilometers from Earth, JWST observes the universe in infrared light, allowing it to peer through clouds of cosmic dust and examine objects that were previously impossible to study in detail. Its spectacular images often capture public attention. Yet its most revolutionary discoveries come from something far less dramatic. Light. When an exoplanet passes in front of its parent star, a tiny portion of starlight filters through the planet's atmosphere before reaching the telescope. That light carries chemical fingerprints. By studying these faint spectral signatures, astronomers can identify molecules such as water vapor, carbon dioxide, methane, and other compounds that help reveal the planet's environment. This technique has already transformed planetary science. For the first time in history, humanity can investigate the atmospheres of worlds orbiting distant stars without ever leaving our solar system. Each observation teaches us something new. Some planets appear far hotter than expected. Others reveal unusual cloud layers or exotic atmospheric chemistry unlike anything found on Earth. Every discovery expands our understanding of what kinds of worlds exist across the galaxy. And perhaps the most exciting realization is this: life elsewhere may not resemble life here at all. It may thrive beneath frozen oceans. It may survive inside dense atmospheres. Or it may exist on planets unlike anything our imagination has ever created. The search for extraterrestrial life is no longer limited to science fiction. It has become one of the most active fields in modern astronomy. Whether the first evidence comes from atmospheric chemistry, unexpected technological signatures, or an entirely new phenomenon no one has yet imagined, one fact is becoming increasingly clear. Humanity has entered an era in which answering one of its oldest questions is no longer beyond the reach of science. And if that answer finally arrives, it may change our understanding of the universe forever. The James Webb Space Telescope has already changed the way astronomers study distant worlds. But perhaps its greatest contribution is not a single discovery. It is the realization that planets once seen only as tiny points of light are becoming real places with measurable environments. Every spectrum collected by JWST reveals another piece of a distant world story. Some planets are wrapped in scorching atmospheres hotter than molten lava. Others appear covered by thick clouds unlike anything found within our solar system. A few occupy the so-called habitable zone, where temperatures might allow liquid water under the right conditions. These worlds have become the focus of one of astronomy's most ambitious goals: finding evidence that life exists beyond Earth. For decades, scientists searched primarily for radio signals. The idea was simple. If another civilization developed advanced technology, perhaps it would communicate using powerful radio transmissions similar to those humanity has produced for more than a century. Projects dedicated to listening for such signals continue today. Yet astronomers now realize that intelligent civilizations might leave many different kinds of clues. Instead of broadcasting messages across the galaxy, they may unintentionally reveal themselves through technology. Scientists call these possible clues technosignatures. Imagine a planet whose atmosphere contains industrial chemicals that rarely occur naturally. Imagine enormous solar energy networks producing unusual patterns of reflected light. Imagine artificial heat escaping from large cities or massive engineering projects visible only in infrared wavelengths. None of these observations would immediately prove the existence of an alien civilization. Natural explanations would always need to be investigated first. But unusual discoveries like these would encourage scientists to look more closely. This careful approach defines modern astronomy. Extraordinary claims require extraordinary evidence. Every surprising observation must survive repeated testing before becoming accepted science. History has shown why this caution matters. Many discoveries that first appeared mysterious were eventually explained by new measurements or improved understanding of natural processes. That is not a weakness. It is the strength of the scientific method. The search for life beyond Earth is becoming increasingly sophisticated with every new telescope. Future observatories may be capable of directly photographing Earth-sized exoplanets, separating their faint light from the overwhelming brightness of their parent stars. For the first time, scientists may one day observe continents, oceans, clouds, seasonal weather patterns, and perhaps even signs of biological activity on distant worlds. That possibility is no longer pure imagination. It represents one of the long-term goals of modern astronomy. Whether the first confirmed evidence comes from atmospheric chemistry, unusual surface reflections, or another phenomenon nobody has predicted, the discovery would transform civilization forever. Its impact would extend far beyond science. Philosophy, history, religion, politics, and culture would all confront new questions. If intelligent life exists elsewhere, how common is it? How old might those civilizations be? Have they explored their own galaxy? Do technological societies survive for millions of years, or are they rare and short-lived? No one knows. For now, humanity continues searching with patience. Every new observation adds another piece to an enormous cosmic puzzle. Most reveal natural explanations. Some raise entirely new questions. Each discovery expands our understanding of what is possible. Perhaps that is the greatest lesson of all. The universe is not becoming more mysterious because it is changing. It is becoming more mysterious because our ability to observe it continues to improve. The James Webb Space Telescope represents another step in that remarkable journey. It allows humanity to study worlds that previous generations could barely imagine. It reminds us that every distant star may host planets with their own histories, climates, and possibilities. Some may be barren. Some may be filled with simple life. And somewhere among the hundreds of billions of stars in our galaxy, there may exist a civilization looking toward the sky and wondering the very same thing we ask every night. Are we alone? Until science provides a definitive answer, the search itself remains one of humanity's greatest adventures. Because every time we build a better telescope, extend our reach a little farther into space, and ask a better question, we move one step closer to understanding not only the universe around us, but our place within it.